Hello. So today we're going to be looking at in Python, or what does it look like? So this is what do you call it? A visual of how sections like trees, people queuing up in a line. After this person, you get the next person. It is in form of a straight line. That is how linear collections, with regards to see how we can organize and manipulate data using linear collections, and we're going to see some of the applications of linear collection using Python as the programming language. We'll consider to be linear. Dictionaries are constant arrays. Array is a type of data structure in programming, not just peculiar to Python. Python by inbuilt doesn't have arrays, but it is part of Python standard library. We can also make use of the arrays. In some programming languages, if you want to have a list of things, you normally use arrays. So one thing about arrays is that, when you are defining a list in Python, you can have string homogeneous, which is a list of, and in Python, lists are items there when you are defining the fixed size. And what does this can do in arrays is that you can also going to look at another thing that still define an array using the arrays library. So here I'm going to import arrays. Import array. ARR as array. Sorry, I'm going to put so if you want to define type code actually represent the precision. So let's go for I. Then after this, you are going to provide the. So one thing about this array is that what we mean by fixed size is that there are 5 elements here. By defining this array, we can no longer adjust it. We can no longer, and this is an integer type. Actually derive the list from call is a combination of that is. Let's define a list here. So there are 5 items in this list. If you look at this list, this is, and these values are. So what this means is that these 5 boxes doesn't hold the values. Instead, it holds references to the values. I can easily use slice to, I'm going to put a colon here. So let me go ahead and print num1. So this is going to give me the initially defined list upon which it is. So let's go ahead and run this. So this is going to give us the same thing. Then pay attention now. I've defined num2 by copying 1, and I access one of the elements, which is the first element, and I give it a different value. Let's see. You can see that. Okay, so let's have num1 is equal to this. Item in the num is equal to 0. Num1 is equal to nums. And I have changed the value to a different thing. You can see this one is now showing us. And then this secondly, first item in num1, and ultimately from what we saw here, this also changed the value of nums. So what happens here is that it is only holding the references. We have boxes here, which are addresses in the computer memory. So each of these boxes point to a value. Each of these boxes point to a value. So if that is, but we have another way of making a permanent copy. So, and this brings us to what we call this. What I'm doing is called a shallow copy, because the second list is also sharing the same copy, deep copy. So for me to do copy, so now instead of saying num1 is equal to num2, I'm going to say num1 is equal to copy. So let me go ahead and print num1. So we'll have same thing, which is 1, 2, 3, 4, and 5. But if I do something like num1 and 100, And this is going to give me no longer having the same, sharing the same references. Let's go ahead and print num1. Yeah, the change is supposed to show. So this is the changes. So if you want to make a permanent copy of a list, you use deep copy. But when you just do normal assigning a list to a different list, or even do next thing we're going to do now is that we're going to look at, we've looked at arrays. Apart from being homogeneous linear connection, they are sequential. Sequential in the sense that if I have has an index of 1 and 2, you can see they are sequential. One is leading to the other, one is leading to the other. And arrays are 0 index based, 1 and so on and so forth. So we've looked at arrays. We said arrays are homogeneous. Then arrays are also fixed size. Fixed size meaning that if you want to define an array containing 5 items, so if I want to define an array on ground, what I can do is I can say, let's still import the array. So have from array, and I can have this as array, and I'm going to provide the type code. So let's call it for 5. If I don't know what to, so what this means is that if I have any need of a certain more items in this array, the array becomes filled up. Once the array is filled up, it means I can no longer make any addition on the array. Sequence an index of 0 and then the last item in the array to manage. Difficult to manage in the sense, in Python I can define a list like this. Maybe nums is equal to, and I have only, I can even start with an empty list. If I want to add an item to the list, I can say nums.append arrays. It is not possible. You cannot do that. And this brings us to what we'll call dynamic arrays. Dynamic arrays are a type of arrays whereby if the size or the capacity of the array is exhausted, the array can adjust, can resize itself. Typically, look at how it works. Assuming you define an array to have 2 items and the capacity get filled up, what happens is that a dynamic array is going to double the size of it. It's going to double it in size. So when you exhaust the capacity, it's going to double again to 8. This is how it's going to continually be doubling in sizes. That is dynamic arrays. The size is not fixed. Initially, you define a dynamic array starting with a particular. It will get to a point when it becomes full. When it becomes full, it means that it can no longer accommodate more items or more elements. That means talk about referential arrays. Referential in the sense that the arrays doesn't hold values. Instead, it holds references to where or place, that is the place in the memory where the values are being stored. Array or one list another one, you are simply making a copy. That is the new array or list you are creating is still sharing the same values. So that is referential arrays. A class designer, maybe you are to develop library. Let's say you are developing a new programming language, or you are developing the array class for Python, and you know how arrays work, but you want to implement those functionalities. We're going to learn how to do something like that. What are the things you can do with a list class? You can add items to a list. You can remove items from a list. You can insert items in a list. You can create a list. And you can also determine the length of a list. These are some of the common operations that you can perform on a list. How do you go about it? That lists are dynamic arrays. In as much as you can easily, perform those operations on a list, even though the list is filled to the capacity, but you don't get to notice it. The reason is because it is being handled internally. So we're going to be creating an array that resembles the list class that is dynamic in nature. You can perform on a list, like indexing. You can do remove items from the dynamic array or add new items, and so on and so forth. So for us to implement this, we're going to be importing the C types. C types. That is where we're going to be starting from. And the reason why I'm importing the C type is because we're going to be using this C type. So for this class, we can call it class dynamic array. Initiate a class. The constructor class runs. That's the first code that runs. It's just like when you want to create a list, you can easily create an empty, actually invoking the for you. So we want something similar for our dynamic array. We want to create a data structure that you can instantiate. So, and double underscore. So the number of items that the list, the dynamic array is going to hold, and we're going to assign it to be 0. So in essence, we're trying to create an empty dynamic array. So what I'm is equal to 0. So this is an instance variable. This double underscore n, we're going to specify the capacity. Of course, you know that lists, arrays are fixed size, they have a capacity. So we're going to have self dot capacity is equal to, we can start by assigning it to a value of 1. For you to add another item to it again, it has to double the size of the capacity to 2. That is 1 times 2, giving you 2, which means it has to double again. That is 2 times 4 times 2, giving you 4. So you have extra 2 spaces to provide at this point. And I'm going to define a function or a method that is going to create our array for us. So for this, I'm going to be calling it make array. So we can call it DEF, and create an array. You indicate the capacity, how many slots you want to make available for the array that you want to create. So for this, we create an array. You can also actually import the built-in library, but for this example, for most example, you are going to. So I'm only going to be using these C types, and for us to get something like to get an array, we'll simply do have C types, which I've already imported. Dot py object. This is going to give us the array. So I'm going to be completing this instance variable is going to hold our array, so I can keep it as A. Then I'm going to be making use of the make arrays method, which I just defined now. I'm going to be passing in the capacity. So have self dot capacity. So this is going to be creating our array for us. Is what if you want to determine the length, that is the number of items in your dynamic arrays, that is the length of your dynamic array. So we're going to be using operator overloading. So we're going to have def double on. To do is that it is going to return the number of items currently present in that dynamic array. Instantiating our array with a capacity of 1. This capacity means the number of items it can, the maximum number of items it can accommodate n. This is what is going to give you the length of your array. Then the next thing we're going to do is, so we're going to be using item, and we're going to be providing the index. So what is going to happen now is that actually indexing is equal to, and then you provide an index. This index is what we'll label as care. So this is going to represent. So for this one, the first thing we're going to do is we're going to check array, and this dynamic array has 1 and 2. and somebody provides an index of 2, we're going to get an error because there is no item in the index 2. This is what index is, if 1, and that is what a valid index should look like. 0 less than or equal to care, and care less than self condition. Do you understand? That is not. But if it is not, so let me space out this. So we'll have raise index error. So raise index error. And for the index, you can say you want to throw. If you didn't get to this condition, what it means is that the index is a valid index. That means you should go ahead and get the value associated with that index. We are trying to use for indexing is a valid array. So this is our array. Self.a is our array. This is the one we just created using the big array method. So we'll have return the value at that index. Okay. Then the next thing we're going to this, and I'll put a slicing operator and then put 0 double underscore set item. So for this self item, we're going to be needing self here, which we're going to use to change update. Go ahead with updating the dynamic array. We'll have to confirm that the index is a valid index. So if this is the case, that is, if it is not a valid index, it should raise an index error, which is what the change is. So what I'm going to do is we're going to have self.a, which is our array. Then we're using our slicing operator and then target the care element. Then we'll assign it to the. So item, this is almost like indexing. How to update item in a given position. So we can call this, while this particular one are the public interfaces upon which you can perform operations on the dynamic array. So if you want to make an append, of course if you want to make an append, find a way to determine. We have a dynamic array here, or we have an array here. Arrays are fixed sizes. So one of the things you should be worried about is the place where I want to append this value. Is it available? If that means, is there space for it? If there is no space for it, it means that the dynamic or the array is of full capacity. So it means you need to double this capacity of the array to make room for new items. And this is what we're going to establish here. So we're going to, it means it is full. You need to double it. So we'll say if self.n is equal to self.capacity. Is equal to self.capacity. Let me put pass here. So what I'm going to do now is that I'm going to be creating a method that will help me double the size. That's the first thing we're going to do. So have self. Then afterwards, we're going to put the capacity, the current capacity. So what I'm going to do now is that I'm going to create a new array. I'm going to make a copy of our is equal to self.a. This is making a copy of the array. Then after making a copy of the array, I'm going to increase the size. Then if I increase the size, then what I'm going to do now is I'm going to perform a loop on the items, the current items in the array. So we'll have 4. I can use for j in range self n. That is the loop I'm going to perform. So what I'm going to do now is that I'm going to assign the values a to space new array, then we'll target the index, which is j, is equal to new array. So just simply what I'm going to do now is, I think there's a mistake here. The mistake here is that I'm supposed to create a new array of a double size and then transfer the contents to the new array. So here I'm going to use the original capacity multiplied by 2. So this is capacity, that is capacity multiplied by 2. This is what we intend to achieve, and then we'll now transfer so we'll transfer the content of the new array, the old array, into the old new one. So this is the new array, this is the old array. So that is what we achieved with resizing. So having done this, let's go back to our append method. So for this append method, if this is the case, then we need to resize our array. So what is the array? So here we have self.resize. For the resize, I only need to provide the capacity, and the current capacity is self.capacity. That is the current capacity. We'll perform the appending operation. So the appending operation has to be done at the index, which is -1 of the total number of items in the array. So here we're going to have self.a. If we're doing that is if the n array, what it means is that the last item in that array has an index of n-1. So if you want to make an appending, you have to do it at n-1 plus 1, which is equal to n. That is what we're going to do now. So we're going to be targeting self.n as our index. So we'll have self.n. Then we'll now assign it to the value in the array equal to 1. So this is going to increment it. We added one item, so we need to increment the number of items they count. So, and that is by removing method. Or let's look at the insert method first. Appending means adding to the last 1, 2, 3, 4, and 5. If you want to make an insert, you need to provide the value and the index where you want to make the insertion. So assuming you want to insert at this point, pay attention very well. If you want to insert at this point is 0, 1, 2, 3. We want to insert at position 3. What it means is that you need to shift this one. What we're going to do now is that we're going to, and for this insert, we're going to be needing the index and the value. So how we perform this operation, we need to confirm that the index is a valid index. So I'm going to copy this conditional that we have here. So let me copy the entire conditional and the erase, and with our insertion of index. We also need to check whether the dynamic array is of full capacity, whether there's a space for us to make our insertion in the first place. So what we're going to do now is that we're also going to copy this formula where we had to do resizing if the capacity, that's the number of items, is equal to the capacity. We're going to copy that as well. So I'm going to copy this and then put it, sorry, not all of them. I need to copy this a size if it is of, there's a space for insertion. If there's no space for insertion, it's going to resize it, multiply it by 2. But if there is space, it can now commence with the insertion operation. So the first thing we need to do is we need to identify where the insertion is going to take place. If we identify where the insertion is going to take place, then we can now perform a loop starting from so what we're actually doing is this. We'll have 1, 2, 3, 4, 5. We want to make an insertion. We want to make an insertion at this point. So what we're going to do is that this one will shift by 1. This one will shift by 1. And now we have this place. this is where we want to do our insertion. So first of all, we are going to perform a loop starting from the last index plus 1, because the last index is n minus 1. So the last index plus 1 all the way negative loop, so that it will start from the last and stop at a value that is a position before the. For this, we are going to be starting from the last is a space, that is a position after the last item, and that then we are going to be stopping at k, and it's going to be a negative loop. So having done this loop, we're going to assign the last item, that is the item at the index of self.n minus 1. That is, we're going to assign value. Have something like this: 1, 2, 3, 4, 5. So this is what we're trying to do now. We're trying to, we want to make our insertion after the 2. So what is going to happen is, I'm going to put nothing in it to the value at the index of 4. So here becomes 5. That is the index of 5. Because I'm making more. This one is 4. This one is 5. A number, 5 items. This one is going to be 6 items. Then the next one now, because there's no more space here again now, so I'm going to assign 0 to the new value. That is what we're trying to do. So what we're now going to do is self, and the array is A, and then for the index is going to be J. Remember what this is actually providing us the values. So if there are 5 items in that dynamic array, if there are 5 items, we're now assigning it to a different value, which is the one before it, that is self, the essence, j minus 1. Then after doing this operation, we want to now assign the value to the one that space remaining, that position k, because that position k will now become vacant. Remember that when you are doing generating a range, it's going to start from the start of it is untouched. We're only updating the value there. So here we're going to after doing this operation, we can now have self dot a, which we're going to be providing during the insert operation. Then after the insertion operation, we are going to increase the number of items in the. So we've looked at 2 ways of adding items to our dynamic array. Let's look at how we can remove item from the dynamic array, and it's still the same principle. So have df remove, and if we're removing item, we're going to be providing the item that we want to remove, or the value we want to remove. So we'll have value here. When you shift the other ones from the right to occupy that position. That is what we're going to do in remove array, and then determine the position where the match is found. If the match is not found, we're going to return not found. So we'll have self.n. We're trying to look through all the items in that array to the value we're trying to remove. So if self a, if we get this, it means that we found it to this. Then we can, after this looping operation, nothing is found, then we're going to raise an exception. So have found. We want to remove is located. The next thing we're going to do is to shift the other items at the right of it to occupy the position. So we to the last item, j in range to the item, because if we shift it back at the end part of it, at the right end part of it, so we'll have self dot n. That's making our shift. We'll now start assigning that value in that position we want to remove A equal to position entirely. So this is going to J minus 1. That is what we're trying to do. This is the position. Then after this operation, you are going to decrement the number of items in your then minus equal to 1 to remove it, to reduce it by 1. Or can simply write return here to terminate the run. Then another popular operation you can also perform is a pop operation. Perhaps maybe you can do that one later because we're going to implement our str method. So here we're going to have str method in the dynamic array, appending it to each other. Want it to be listed for n in 2. I'm going to use f string here. So we have a placeholder self.a, then we'll get the item in that position, which is n, and we want to have a space in between them, or if you will now return the output. So with this, we've been able to implement a dynamic array. What we're going to do now is that for dynamic array, provide an empty one capacity and nothing inside of it. That is what it is going to do. Then let's say we want to append item array. If dynamic array has no attribute capacity in line 17. So let's see where the problem is coming from. I'm supposed to use printed an empty dynamic. Let's say array.append array.append. So let me copy this as many times as possible. So let me change, even use iteration to add multiple. Something I am not getting very well. So this is this is this, except if I deleted something mistakenly. So let's go back. So this should work, or better still, a loop. Something is happening at line. So self.n problem is coming from is equal to value 1. I think whether it is resizing properly, capacity times 2, and this one is this. I can sort out and see where the problem appending, and then the append method. So let's method t resize and array of times 2 capacity. We're trying to be 45, which is n plus 1. Let me remove this value from here. So let's dot a dot n valid index. It. We did not, is not working out very well. So but here